So we're continuing with section 5.3, and this is our question 1. An antiderivative of a sum of functions f plus g is an antiderivative of f plus antiderivative of g. True or false? And let's pause and come back. So let's say antiderivative of f is the capital F. One antiderivative, and antiderivative of g is capital G. Then this is asking, is antiderivative of f plus g f of x plus g of x. Is that an antiderivative of f plus g? And so if I take the derivative of this side, I end up with lowercase f plus lowercase g, and that is true. Okay. I click question 2. An antiderivative of a product function f times g is an antiderivative of f times an antiderivative of g. True or false? So let's pause. And the answer is false, because if you're saying f of x times g of x is antiderivative of f times g, and if I take the derivative of this, then I end up with f of x times g of x plus, by product rule, f of x times g of x, and that is not equal to f times g. Constant and sum and difference rules. Let if capital F of x and capital G of x be antiderivatives of f of x and g of x respectively, and let c be a constant, then c times capital F of x is an antiderivative for c times lowercase f of x, and capital F plus capital G of x is an antiderivative of lowercase f plus minus g of lowercase g of x. And so that was the basic. The second part is what we did in I click here question 1. We don't have any specific rules for product or quotient or composition as we did with derivatives. So calculating antiderivatives are significantly more complicated than calculating derivatives. And so then, and specifically, we don't have any product rule, we don't have any that sort of things. In chapter 5 and 6, we're going to develop some techniques, and some of them comes from basically chain rule, and some of them come from product rule in derivatives to take care of some of the product and quotient quotients that we want to find the antiderivatives of. But it's not, there's no rule. It's just different techniques that helps us take care of those type of functions. So let's start doing a few antiderivatives. Let's say this is the function f of x. How do I find the antiderivative. Again, antiderivative starts with that elongated sum sign, and then you use this. Then you put a dx. That means that you're taking the antiderivative with respect to x. Now, if you remember, the sum rule is the opposite way of the the power rule is the undoing the power rule for the derivatives. So undoing power rule for derivatives is that first you add to your exponents of 1/2 stays. Let's say this one is the first one that I'm doing. 1/2 always stays. X to the power 1 more, which is 3, divided by 3. And then minus 2x. Again, when you, the first step would have been that you take that 1/2 out, x squared dx. Again, take the 2 and minus out, x dx. Take the 6 dx. So that would have been the first step. But how the process goes after that is that you just realize that you're taking antiderivative of each term. That antiderivative of first term is that 1/2 x to the power 3 over 3. Antiderivative of second term, see the second term, is going to be again the constant, and then x to power undoing the derivative, 2 divided by 2, and then the third term is going to be constant. And what is derivative of a constant, and what is it? What derivative is going to be a constant? That constant times x, and then you add a c. So the entire process becomes, if you clean it up, becomes x to the third over 6 minus x squared plus 6x plus c. And so c is for general antiderivatives. That means that all that you had here plus added any constant, because all constants will go away and through the process of taking derivatives. When you're taking antiderivatives, you want to bring them back in, but you don't remember which one it is because every constant goes to 0 through the process of derivatives. So when you're doing the anti, you basically put in a constant and you don't know what it is unless other information is given. And so this becomes, with that c, becomes the general antiderivative of that function. So we tried so let's do one more antiderivative. I'm looking at this function g of x equal to x plus 5 times 2x minus 6. Again, we don't have a multiplication rule for antiderivative, so we have to find something else at this point. And even later, we just will have techniques. Here, though, I know the only technique that I have is the algebra of things. So what I do is I basically FOIL these two together, so I have different terms rather than a product. And so when I FOIL things together, then I get basically this value. And so now I try to find the antiderivative. And as I'm finding the antiderivative, again, if you remember last time, we're going to do first the first term, and then the second term, and the third term. And so the first term, 2 is the coefficient, then x has to, we're doing undoing the derivative, so I have to raise the exponent to 3 and divide by 3. Here again 4 is the coefficient, undoing the derivative, so I go to power 2 divided by 2, and then minus 30, undoing the derivative, x was there, x to power 1 over 1, and plus c, so it will be general form. 2/3 of x to the third plus 2x squared minus 30x plus c is the answer. Now, let's find another antiderivative. This time it feels like it's a quotient rule. Again, we know that there's no quotient rule for antiderivative, so we have to do something else. Do the algebra. So I write this as 3 over square root of t plus t over square root of t plus t squared over square root of t. And then I clean it up a little further. This is 3t to power negative 1/2. This one is t to power positive 1/2. This one is t to power, so 2 minus 1/2, which is 3/2. Now take the antiderivative. And remember again, we're doing each term separately. And so this one is going to be 3t to power negative 1/2 dt. That one is t to power 1/2 dt. And that one is interval of 3 to power 3/2 dt. And so they all add up to, first one, coefficient, t to power 1 more, negative 1/2 plus 1/2 is 1/2. Then you divide by 1/2. Then t to power 1/2 plus 1, which is 3/2, divide by 3/2. Plus t to power 3, then half plus 1, which is 5/2 over 5/2 plus c. So when I'm saying over 1/2, that means that I have to multiply by the reciprocal. So I get 6t to power 1/2. Here by reciprocal, I get 3t to power 3/2 divided by, 2 divided by 3. And then for this one, 2t to power 5/2 t and t divided by 5 plus c. And that becomes the antiderivative. Now, how do I take the antiderivative